Now problem, uh, the same kind of problem it was asked in a winter 2018. Same kind of problem it was asked in a winter 2018. The question is like this: during the trial of single cylinder, means K is equal to 1, 4-stroke engine, the following results were obtained. The cylinder diameter D, it is given as 20 centimeter. I am writing the given data. D is equal to 20 centimeters, stroke is 40 centimeters, means L is 40 centimeter. Mean effective pressure is 6 bar, MEP is 6 bar. Then torque T is 407 Newton meter. Speed and it is given as 250 rpm. Then oil consumption, it is nothing but the fuel consumption. Oil consumption, I am writing F dot is equal to given as 4 kg per hour. Then calorific value of the fuel CV, it is given as 43 megajoule per kg. 1 kg of fuel liberating around 43 megajoule of energy. Then cooling water flow rate M1 dot, I am writing cooling water flow rate, say M1 dot is equal to 4.5 kg per minute. Then air used per kg of fuel, it's air flow rate, air used per kg of fuel. Indirectly it is given as the air fuel ratio, so I am writing it is 30 kg per kg of fuel, isn't it? It's like a air fuel ratio, air to fuel ratio 30 is to 1, isn't it? 30 is to 1 it is given. Then rise in cooling water temperature, let's say T2 minus T1 in our case, so I can write it T2 minus T1 for cooling water, it's given as rise in cooling water temperature 45 degrees Celsius. Then temperature of exhaust gas, temperature of exhaust gas, it is given as 420 degrees Celsius. Room temperature, it is given as 20 degrees Celsius. It's a test, atmospheric temperature. Mean specific heat of exhaust gas, CP of gas, it is given as the 1 kilojoule per kg Kelvin. Then specific heat of water, CP of water, it is given 4.18 kilojoule per kg Kelvin. We have to find out the IP of engine, BP of engine and heat balance sheet. So for the test in a heat balance sheet we have to draw on the basis of kilojoule per hour. So we know that heat balance sheet is nothing but it's a gross heat liberated by burning of the fuel. So it's a input energy, and output of this input energy are the heat equivalent to brake power that we have seen in the last lecture. Second one is the heat taken away by the cooling water, and third one is the heat taken or carried in a exhaust gas, and then heat which is unaccounted. So let's see its solution.